Hey everyone, welcome to the 9th session of number systems only on our e-learning platform Origins e-Shala. I hope you guys are doing fantastic. So as I have been saying since the beginning of the session that these are several use cases where you will find this topic to be the core foundation. And as far as remember, in the last session I had given you guys a few practice sets to check out whether you have gotten the concept or not. So let's tally our answers. Now for 10800, I think it's a very simple thing, because I can easily identify that 108 is nothing but 12 into 9. So from their point, it is quite easy to prime factorize it like this. And I can easily get that TNF is 60, and the number of ways I can write it in the product of two distinct divisors or two co-primes is 30 and 40 respectively. Similarly for 729, I know clearly it is the square of 27, and it has 00, it is obviously square of 100 as well. Sorry, square of 10 as well. So that makes my work a lot simpler, and I can easily identify this like in this way. Now as for 9450, I think it would be quite difficult for many of you to directly grasp it, but yeah, you can at least identify that it is going to be a multiple of 9. So that is one way you can do, and it is okay if you are not able to identify it directly, because this was intentionally given as it is not directly identified in a single glance. So these are the values. I hope every one of you got it right, and you are quite confident that now, okay, no matter what question comes regarding these topics, we can solve it out, right? So with that said, this time around, let's try to find number of co-primes to a number less than itself, because obviously if you count the number of co-primes greater than itself, it can go up to infinity. There can be n number of terms, but that's why what we are interested in is the number of co-primes which are less than the number itself. So let's take 7 as an example to get your concept much more clear of what we are referring to. Okay, so in case of 7, I know the numbers smaller than 7 are these. Okay, and all are co-prime to 7 because none of them have a factor common with 7. Similarly, let's take example of 8 this time. And as you can see, 2 and 4 and 6 have a factor of 2 or 4 themselves in common with 8. That's why all the numbers except these 3 will be co-prime to 8. Now let's take 12 this time to get it more clear, because these were all factors of 2. So let's take a different number this time. Now as for 12, we know up to 11 these will be the numbers, and there will be factors of 2 as well as factors of 3, like 3, 6 and 9. So after removing this, I'll be left with 1, 5, 7 and 11, and these are the number which are co-prime to 12 but less than 12. So are you confident now? I'm sure you are, right? Okay, so let's find co-prime to 580 which are less than it. Sure, right? It's quite simple. You just need to count, right? Okay. I know this is the usual case when in school they teach you x plus y, and in exam it directly comes x square plus y square. So I'm going to walk you through the first step or the trick to how to solve such kind of questions for big numbers especially. Now the trick or the shortcut is simple. You need to find the prime factors of the given number by prime factorization. That is something we have been doing since the factors topic started. So it is very simple. All of you guys can do it, I'm sure. Now the unique thing that we have to do is, whatever the prime factors we are finding, we need to subtract their reciprocal from 1 for all the factors. For whatever number factors I am finding, I have to do a reciprocal and subtract it by 1. And now multiply all these values with the number itself. Done. Don't believe me? Okay, let's prove it. So let's take the same number 8. Now for 8, I know the prime factorization, it's going to be 2 raised to 3. This time I'm not bothered about the power, I'm bothered about the value itself. So what I need, let's call it CTN. Co-prime to the number 8. That's why I'm writing it just to save my time. So 8 into, now what will be the reciprocal of 2? That will be 1 by 2. and I am subtracting it from 1, so I'll be left with 8 into 1 by 2. That would leave me with 4. Now, if you remember correctly, this is the same answer we received by our that usual orthodox method, correct? Now let's try again with 18. This is a new number because you may say that it might be coincidence. So let's try it on 18 now. And I am intentionally taking small numbers so you can verify them by counting it by that old method and matching with the answer of what we are getting here. So 18, I can write it like 2 into 9, that is 3 square. So 2 and 3 are my factors. Now similarly, we have to do reciprocal of 2 and reciprocal of 3. If I subtract half from 1, I will be left with half, and if I subtract 1/3 from 1, I will be left with 2/3. That's what I have written here. Nothing much big of deal. And of course, the answer would be 6. Now, this is a very common trick which you would have visualized just from the last exercise we are doing, right? Because what we were doing was, if we know for a fact that the number is made up of factors and we have to exclude these numbers. Let's go back a bit so I can show you it from image perspective. Now, here we have 12. So we know that 12 has 2 and 3 as the main prime factors. What we were doing? We were removing the factors of 2 and 3. Correct? And whatever was left were the numbers which were not factors of that. Now, for a matter of fact, if I say from 1 to 12, how many times factors of 2 are repeated? Every second time, right? After every one term, I am getting a factor of 2. Similarly, for 3, after skipping every 2 terms, I am getting a factor of 3. That means out of 3 terms, 1 will be a factor of 3 for 3. Similarly, for 2, out of 2, 1 will be a factor of 2. That's why we were subtracting the reciprocal from 1. It was nothing, just finding the remaining. Like I said now, out of 3, 2 are my values which I am after. Like 1, 2 and 3, I only need 1 and 2 in this case if I have to count. So that's why we were doing 1 minus 1 by 3. That gives me 2/3. And we are multiplying it to consolidate all the factors. Half and then 1/3. In this way, it was a simple trick to get it used to. So I hope you guys found it quite useful, and if you did, then a like and sub to the channel would be great. Now let's practice it on a few big numbers which need not be verified now, as you might have already done it. So for this time, let's continue with the task I gave you for 580. So 580 is nothing but 29 into 20. That much I am sure. So 20 is nothing but 2 square into 5. Now the factors are 29, 2 and 5. So 28 by 29, 1 by 2 and 4 by 5. I will multiply them with 580, and you can surely use calculator for such things. And if you find a opportunity to simplify it, then go ahead, you can simplify as well. And I will be left with 224. So this is the count of the numbers which are co-prime to 580 but are less than it. Now, if I were to say what is the generalized formula for this. So let's take a number n, which can be any random number, which is having prime factorization in this form: a raised to p, b raised to q, c raised to r and d raised to s. That means it can be any number and any power. Now we are not bothered about the power in the slightest. What we are bothered about are these prime factors themselves: a, b, c, d and so on. So what are the key ingredients I need to find CTN? The number itself, n, and the reciprocal of the number subtracted from 1, and you multiply all of them. So this is the generalized formula in which you can see that, okay, I can found co-primes to a number less than it by using this methodology. And this formula will never end because we never know for which number factors will go up to what number. It is very random and unpredictable for each and every individual number. So this is the generalized formula which you can, just mark it in your brain somewhere to solve such kind of questions. Now let's practice a bit more, this time with a 4-digit number. We have done 2-digit number, 3-digit number, and obviously now we will go with 4-digit numbers. So same methodology. For 1530, I know that 19 to 17, or more precisely, I know 17 into 9 is 153, because 153 is just 17 short of 170, right? That clearly gave me a hint that I can skip the long method and directly go for 19 to 17. And this saved me quite a lot of time. I directly got 3, 2, 5 and 17 as my prime factors. Now, obviously, I just need to reciprocal number, and you can also remember it like this. Rather than subtracting from 1, just subtract 1 from the number itself and add it as a numerator. That is also one way to visualize it. Let's say my prime factor was 3. Okay. So denominator would be 3 and numerator would be 3 minus 1. That's also one way, because 1 minus reciprocal of number is going to end up the same way. It's up to you how you want to remember it, right? I remember it similarly, that whatever number is bottom, numerator, denominator, numerator would be 1 less than it. That's the simple thing I do every time. So yeah, CTN would be 16 squared, that is 256. And that's here is also one place where you will find that without calculator I can directly solve it, because 390, all of these can be simplified. So, and if you remember squares, 16 square is nothing new, 256 you will directly get. So I hope you guys enjoyed the session. See you again next time. Thank you.